There's some holiday homework to do for term 1 break. So on today's sector page, I've attached a few documents. Firstly, what we need to do is finish part 1 of the folio. We also need to have a good think about the resource study. The video that I've added here is Mr. Lagos, and he's talking about some options for the materials task or the materials testing task. That's the external part of our project. Will be this video that you're watching, and underneath there is a design brief investigation sheet and the transition day information about the course that might be handy to refer to. So this is the PowerPoint that is transition day 1. We've already done this task. So this is our term 1 task, the skills task for woodwork and metalwork. The grade that I've given you at the moment is a progress grade for the entire project. That will be updated once you've got this together. This is essentially going to be external time now, because we don't want the impact on the progress of the major project or the major solution now. So we need to finish this off in some afternoon sessions after school, which I'll offer. Hopefully you're not too far away from completing this. So if we look at the overall assessment, we've done 20% of the school-based assessment. These are the last 2 tasks. So assessment type 2 is 50%. This is the design and the making of your material solution or your major project, and the design work that leads to the decisions for how to construct that. We also need to link very carefully the resource study. So in the document, the second document on the sector page, this one here, I've broken those 2 assessments up so to show you exactly what you need to do. So I'll open that document for you and we'll quickly race through it. So in the folio, we did this at the start of term 1, but we need to bring it kind of forward now and make sure it's presented really nicely. So we've got a design brief. So within the design brief, do not say what your finished product is going to be. This is just setting a design challenge. So you need to set a criteria that you'll design your project within. So it's definitely before we've actually made any set decisions. We need a statement of intent. So what will the product be used for? We need to define a problem or an opportunity. So is your product going to solve a problem? Do you need a new TV cabinet? Because maybe the existing one is too big, too small, doesn't store what you need it to store. What's the functional outcomes of your product? What does it need to do? You can be really quite concise with this, because we don't want to use too much of our word count. So you just tell us exactly what your project needs to, what does it functionally need to do. So at this stage, we're not actually saying what it is. These are just the challenges that it needs to solve. Aesthetic considerations. Does your product need to fit in with existing furniture in your house? Is there a certain look that you are going for your project? Constraints. There's always lots of constraints, so list some of them. What's your time limitation? That'll be a term to produce this work. Material limitations, the machines. So we got to work with what we've got at the school. Your skill level. Don't design something that's so out there that you won't be able to get it done in the time. Remember, this is an independent task, and you'll need to make sure that you have the skills and knowledge to be able to do that. The availability of materials and components. So just make sure that you're not designing something that you won't be able to find those components. And include a floor plan of where it's going to go. Nothing worse than getting it home and finding it's a little bit too big for what it needs to be, or it won't fit through a doorway. This should just be a little bird's eye view with some measurements on it. It can be hand drawn. Criteria for success. Criteria for success is just an overview of the above. So when you get to evaluating your finished product, how will you tell if it's successful or not? So just a summary of the above. We move into the investigation now. So we need to not just come up with an image that we're going to copy. We want to find several projects that we like bits and pieces of that will solve our criteria, and we will be able to kind of show a really nice visual kind of development of the design. So we're investigating existing products, different systems and characteristics and features to inform the design realization process. So existing products, take some photos of real projects, break it down into small components like the drawer, different configurations of storage, metal legs, wooden legs. Try and work out what you really like the look of. Material options, what are available, manufacturing techniques, and the tools and equipment that are available to us. Over here we've got the performance standards, so comprehensive and insightful analysis of design features of products and processes. So that's the A band that we're trying to meet. All this is only a suggestion, but this is what we're actually marking you against. So please make sure you've got a comprehensive and insightful analysis of design features of existing products and processes. The second performance standard, insightful and comprehensive communication of design concepts using relevant technical language and visual representation. So this is about drawing some images, analysing existing designs, and kind of like explaining how you're going to make it your own. So that's the first section. What I'll show you is the suggestions. So we've got here two projects. This one here, a lot of external research of materials and sourcing of materials, extra cost for materials and fittings. It's very successful, a lot of problem solving, but it's a lot of expense, very heavy too. This one here was the same grade at the end. They both got a very good grade for their projects. But this student chose to work with the materials that are very familiar with us from our minor product, and he used a lot of the processes that he's learnt through school. So designed within the constraint of the materials and processes that he knew. Think about making a fairly small project with interesting features rather than a big project. If your project is big, try and work out how to make it in sections that can be assembled right at the last minute. Remember, this might come at an extra cost because you're using a lot of material. What does a desk need to be? What does a side table or TV unit have to be? Think about this. The televisions in the past were big chunky things that needed a big kind of surface to put them on. Now we have these really skinny TVs. We don't need much depth to our TV cabinet. It's really just a display unit. Same with a desk. Check out the video. It's a desk over time. Basically, we don't store much on desks now, so think about what it actually has to be. Collect some exploded views. These are really great for showing where the like each piece will need for constructing our work. Gives us a good overview of how your work's going to be produced. A few things to avoid. Epoxy resin, we can't do it at school. Happy for you to do it at home, but we can't. It's not allowed in schools. This is a burning process which uses high voltage. We need to avoid that. Anything in this era of construction is going to be tricky with the processes that we've got. So to keep your projects small and keep them appropriate. This slide shows a few images that are really kind of nice, neat projects that would be appropriate for your major project. So I've jumped back to this homework sheet, the Design Brief Investigation Guide. We've gone through the first part. The second part is for your resource study. We want to try and come up with some ideas for your materials testing. So watch that video Mr. Lagos has put up explaining some tests. if you can link this to what you're going to make for your major, it will be absolutely perfect. So have a look at the highlighted sections. You need to identify 2 or more materials to test. State the reason clearly why these materials have been selected. Conduct relevant research. Conduct relevant research. You need to try and look up what the materials, what's the kind of properties of the materials. Don't get too far into this because you really need to apply it to your project. So you can talk a little bit about the chemical and the botanical structures of the timber, but we don't really need to know that. We just need to know how it's going to perform with your project. And we need a method or an experiment to test it. So is it for strength? Is it for water resistance? Is it for the appearance of a stain? Is it for, say, a leg that kind of extends? So make up a couple of prototypes of how that leg would extend in wood or metal. And if it's applied to that process of, like, I want to design something and I want to so if you apply the test to something that's relevant to your project, this one's a materials test. It's in plastic 3D printed, but you could do it between pine and jarrah, maybe timber. And you can graph those results. The SACE board, when they moderate this, they love graphed results, and we've got the testing equipment to do that. Another one, this was a project from a different design course last year, but he was testing these 3D printed sections for a project, and he was designing this clip here. So if you say you're going to do an extendable leg, like I was saying before, you might try 2 or 3 different ways of doing it, and then strength test it, or report back on what's the better process to follow. So hope seeing that example makes a little bit more sense now. So lots of images, lots of kind of testing, lots of commentary around what method is better. So if you can go about designing 2 or 3 tests, just come up with an idea and what you would need to do for those tests, how it will apply to your project. That's what we need by the start of term 2. Good luck. Send me an email if you need any help over the holidays.